Hello, a very good afternoon to everybody. Welcome to Econstruct's online session. In this particular session, we are going to discuss certain things about the definition menu. During the last session, we have seen the analyze menu in which certain advanced features of the ETABS we have learned. Today, we are going to learn the define menu, which is the definition menu. So, before making it too late, let's get started. So, if you go to the define menu, please remember that the define menu is basically for it is considered to be a kind of library. What does that mean? So if you see this over here, we have defined so many sections, beam sections. We have also defined the column sections over here. We have also defined certain brace elements. You know that the line element, we are having three types of elements are there. One is horizontal beam, vertically it is column, and the cross section, the cross elements, which is not parallel or perpendicular to the gravity, we call it as the brace elements. Understood? So we are having all the three elements are defined it here. Okay, so whenever we are calling this as a library, you know that in the college days also we are having a library. Currently in the Econstruct also we are having a library. What does the library mean is, whenever you want to read the book, actually you can go to a library and get the book. Once the reading is over, actually you return it. And the another person also, once he requires, actually he can take the book from the library. Similarly, here also it is like that. The library is, it consists of so many material sections and different properties. If you want to use it, you can use it. If you do not want to use it, you can keep that in the library form only. So, how to use the library repeatedly? That is also another thing. So let's say, for example, if we save this model as a save as, let's say over here, I'll just save this. Okay, I'll just override it. Now, I want to use the same library functions in the new project. How do I use it? So I'll just minimize this. And in this, I will start creating the new model. Now, in this model, I want to call the library of that file, which is true to which we have given. So instead of using the built-in settings with, we'll be using the option which is use settings from a particular model. So you can go there and just say, okay, the software will ask you where is that file. So you can give that file, and then software will ask you which particular template you need to use it. You can go to the blank option and you can start importing the DXF file, which is 2D DXF, 3D DXF, or maybe you can start working with the grids only option where you can apply the beams and columns to the particular grid and start modeling. Maybe you can go for the steel structure, flat slab structure, or the RCC structure, which might be the flat slab with the perimeter beam, waffle slab, or with normal one-way two-way slab. So let's say, for example, I'll go with any of this option. Let's say, for example, I'll go for this option. As I told you, whenever you want to do any kind of research or something, you should be using the template file. So I'll just say okay here because I wanted to show you how you can use the library function. So as you go here, wow, who has generated these many beams? We are calling that from the library function of the project, which is this particular project. So 150 by 450, we'll just see the last one, and then there is a dummy B something. So if you go here, there is a dummy B, something is there, and there is 150 beam B 150 by 450, which you can use it over here. So can you use it one library? If you go to a college library, you can use the book only once. But if you create the library over here, you can use this functionality in multiple projects. It's not like you can use it only as once. So that is one of the very big advantage when it comes to the define menu. So whatever in today's sessions in the define menu we are going to learn, those would be your library functions. Means whenever you are defining it over here, it will be available to any further projects. Understood? Okay. Now this is a very big advantage where you don't need to define lot many members together. There would be certain disadvantage also. Why? Because you are having unwanted, let's say I do not want to use this beam or something, but it is there just as a part of your library. You should, if you want to use it, use it. If you don't want to use it, you don't use it. When this is mandatorily required, compulsory required, it is definitely required when you go to the steel structures. So let me show you what it is. If you go to the, let's say, import certain properties like I sections, and in this particular, the vendor is having ISHB certain elements, or ISJB or ISLB, or maybe certain elements which are related to ISWB and MB. If these elements only are available in the market, in the area where you are basically designing, or maybe you are executing certain projects, let's say for example you are working in Kanpur, or maybe you are working with some taluk place, let's say for example Shirur in Maharashtra or Daund in Maharashtra. You go to certain place which is not very urbanized place or not very very rural place. So only few limited only few limited elements would be available with you. So just say OK here. Once you say OK and OK here, you will see that also is added in the library. So now this is very interesting in the library function. Why it is? You are importing the library from the previous file and you are cumulatively adding certain files into this particular file, which you can utilize it in the further projects also if you want to. Okay, so this is a very very big advantage that is available, particularly in the steel structures. That certain sections are easy to use, easy to arrange, easy to assemble, easy to erect. So what you can do is you can go to the steel section. Instead of importing, you can go to the add new property and you can go to, let's say, the section designer. Here you can go to, let's say, any of the steel structure, maybe general steel section, and you can create your own functionality. Like let's say for example you want to use the channel section which is back to back, for example. So you can use this function. So this will act like your own column. So isn't it great that to use this kind of functionality? Okay, this is one. You can utilize certain functionality. Let's say for example, I want to use one more type of column, which is we call it as the built-up section. Please understand this what I'm saying. So I'll just go here and I will add the built-up section like this. This is 4-angle section, and later on we will be giving the lacing. What does that mean is, like let's say for example this is the section. When this particular section you can define it only in the SD section, which is section designer. Okay, in the section designer you will be using this. Now, I would just wanted to show you a few more things. Let us say that this is the section that you are using. This is basically a straight line. Yeah, this is another straight line. But you want to use it as a monolithic or maybe as one section. So of course you require it to be getting connected. So that's the reason what we do is we make this kind of arrangements. And the same thing which goes like this. Okay, so what happens is there would be certain lacing here. I'll just put it in some another color so that a little brighter color. You will be having certain lacing like this. So this is this color. Okay, and this particular section which you are defining it, that is this one. So what I'm trying to show you is such kind of library. So this is a unique section that you are going to create it. Alright, so that is created already in the section designer. How many times you will be creating it? You know the property of this, certain property of this, certain property of this, certain property of this, and all. So how many times you are going to define it? Only once. So you just define it over here and add it as a part of your library function. Maybe you can give whatever you want to say. I will give the built-up section. Four channels, and I'll give that some particular code name. Let's say for example 01. So I'll be giving this and just say okay here. And it's not 4 channel actually, it's a back-to-back angle. And if you want to give this over here, you can just copy this and add it over here. So this section will become like this. Understood? So this is the power of creating this section or the definition library. Understood? Now, this is not only one thing that we are going to learn. We are going to learn most of the definition menu functions as much as possible so that you will get to know many things over here. Let's go one by one. So let's go to define and material. By default, as you know that the steel, concrete, others and certain elements would be defined. By default, it will be taking certain American sections also. So either you should use it or you can delete it if you want, but if you have used it, this delete option will not be available with you. Alright, and another thing is you will require certain grade of concrete also, which is apart from just this concrete here, M30, M50, and try to give the meaningful names so that it will be useful for you. So let's say for example you add as per the Indian and you add FE250. So here you add the same name as FE250, which you can utilize it for the steel structure. So this column I'll be giving this FE250 grade. Alright. So this is how actually you will be adding the steel grades and all. Generally speaking, somebody will say that, sir, I do not have FE 345 or 250. I have something else, or maybe 320 grade, or maybe FE 150 grade. How do I add it? No problem. You can just say okay here and add it. And here you can edit it as this is, let's say, 200 grade. And you will give accordingly what is the E value of 200. You will also give the property over here which is utilized for the design data. So instead of 250 here it would be 200 and consecutive properties would be given over here. So yes, you can use the customized format. These are the prerequisites actually, the predefined formats are there. But it is not mandatory for you guys to give this only 2 elements. You can again change it, you can give certain parameters and properties and change this. Alright. Now, apart from steel and concrete, now concrete, how many elements are there? Similarly, it applies to the concrete also. If I want to use M70 grade, it is not there in the library. So how do I use it? So you can go to, let's say, M60 grade, just say okay. So here, instead of M60, you give this, type it as M70, give the property, this is 25 only. The E value is, depending upon the code, we will give 5000 root FCK, or in certain other codes it will be different. So based on that, you give this value. Another thing is design data. Here you need to give 70, which is M70 grade of concrete, 70 Newton per mm square, which is MPa. That you need to give and just say okay, which would be applicable over here. Alright. So like that you can start building up the library functions for the material data. If you want to use certain materials as the time dependent and other parameters, that also you can give if you want to. So let's say I want to use M70 grade, which is little non-linear. I don't want to use the shrinkage. I want to use creep and let's say the compressive strength. Just say okay here, and I'll give here N as a non-linear. So either you can add a copy of this, let's say M70, and I'll not be giving any of the non-linear properties. So you are having M70 non-linear and also you are having M70 linear. Okay, so this is how actually building up the data will be there. Another few things I wanted to tell you is aluminum properties, cold frame properties, rebar. Many people have started using it. FE 415, FE 500, FE 600, 550 is also available. 600 also in certain rare areas it is available. You can go for tendon properties. This is basically the tendon. If you can see that the value of E is comparatively quite higher than just the steel. If you go to the rebar, actually, I'll just go to the rebar. The value is almost 200,000. So that value has been increased. So let's say, for example, if HY is 500, if you give the tendon property, I'll add the tendon property. So tendon property will be, instead of 200,000, it would be 196,500.6. Now this is the E value. Major is this one, which is how much is the Fy and FCU, or tensile strength, or the yield stress. So these are basically the tendon values or the property data. If you want to use it, you can use it. Another thing is, in this case, we are having masonry value also. So let us say, for example, you are having, this is the masonry wall. What is the weight per unit volume? You can calculate and give. E value also you can calculate and give. And if you want to go for design, what is basically the compressive strength also, it would be possible over here. So everything is customizable. So masonry wall, let's say for example in your building, there is one wall which is the masonry wall, brick wall. So some people will say, oh, wall के ऊपर beam चढ़ा देते, we will have the beams on this particular wall, so no need to have columns and all actually. If that kind of things are there, generally if you go to the rural places, you will see most of the retaining wall structures also. So in that kind of cases, what you can do is you can define such kind of walls and materials, and then you need to define the wall also. Let's say for example I want to use 300, I'll be copy as 300 W300 masonry. So here I'll be using the masonry as the grade, same 300. Instead of thin shell, you can use the thin shell also by giving the certain stiffness modification factor. I'll be showing you the how to use the masonry wall also to certain extent. So let's say for example this is masonry wall, and now I wanted to model it. For example, so this one I will be choosing this as a masonry, and let's say there is a wall going here. I'll be calling this as all floors. So from here to here, here to here, and here to here. Since there is a wall, I'm sure that you might be knowing that there will not be any beam or a column or something like that. So I'll be selecting it and I'll be going to the edit and delete it. Okay, so there is only and only currently the RCC, this kind of wall is available. Now this wall is basically the masonry wall. And you want to utilize this as only the gravity wall, because you know that the brick and all actual mortar is not going to work with the horizontal forces. So what you do is you just select that wall. So I will do that first. So you go here and select this wall first. Okay, so you can see that this wall is selected, and from here you can go to the shell object and give the particular stiffness modifiers, or maybe you can give the stiffness modification factor through this also. So how do you do that? You go to the modifiers and F11, which is the horizontal force, resistance force, you can give that, let's say for example 0.7. Vertical force I will begin 0.001, because I don't want to utilize that as a vertical elements. In that case, the vertical stiffness would be very less. So in this case, it will be utilizing only for the horizontal shear resistance. Okay, and rest all actually I'll be copying it as same. Also out of plane shear also I will not be giving anything. Now this is only if you want this shear wall to resist the lateral forces, not the vertical forces. Generally, particularly in this particular project or the example, I want that to utilize as a vertical element also. So I'll be giving 0.7 here and 0.7 here. So it will be utilized the F11 force, which is the shear force, and F22 force, which is vertical force. Understood? So this is the way actually the bending action also it will be taking very nominally. It will be taking just the gravity force and some kind of shear force in its own plane. Okay, so this is how actually you will be defining the wall, which is masonry wall. So please make sure that don't define just the wall here and just get rid of it. No, after defining the wall you need to idealize it. Okay, I am forgetting the name of the person. I think just few days back, one of the person, I think some Singh, is Punjabi actually. He has called regarding the how much amount of lateral forces the shear wall need to be resist if it is masonry. He has already got the job in certain companies in Delhi. and while designing certain project he was facing this kind of problem. So I thought of addressing that issue right away, right now. Okay, so this is how actually you will be defining the wall, which is masonry wall, and give the stiffness modification factors. So we have defined the materials here. Now there would be certain, like I want to use the glass, for example, toughened glass. Okay, and certain structure is there. So you can go to the others and you yourself define all these properties based on the whatever the material that is available with you. So that is possible through this. So this is a very good functionality that you can utilize it. The second one is the section properties. So most of the section properties I have already shown it to you, define it to you. So I'll not be going to those. But some of the properties you might not be knowing. So that is what actually I wanted to show you. Concrete properties, the rail section, T sections, and the precast sections would be there. Okay, so if you go to the precast sections and all, if you want to utilize or import certain properties as a precast element, as a rail sections, you can utilize it. You can give this properties and start. This is a precast element. Okay, so you can give this and start analyzing it. Okay. Another thing is the rail section, T sections. I generally don't prefer that you guys to use it. Why? Because when you go for the thin shell element, the T section will be automatically considered by the program because you are taking the slab as a thin shell element. But if you are using the slab as a membrane element, I would suggest that you go for the T section, because you are not considering the thickness of the flange. You are taking just the thickness of the web. You are not taking the thickness of the flange and the width of the flange. Understood? So you can utilize in that particular case if you want to. Right? So we have seen these two now. The steel sections, you are having the pipe sections, box sections, channel sections, and eye sections. If you want to use the composite sections, which is predefined sections, you can utilize it from here. And if you go to the special sections, actually, now this is very important. The section designer, actually, I have already shown it to you so many times. But few things I wanted to show you now, which might not be there in this particular version, but you can go for checking and designing. Most of the times, actually, in the section designer, people are preferring for checking options. So the default option is basically there in the checking menu. So whatever the sections that you are going to define it in the program or in the project, you are going to just check it whether it is safe or it is not safe, or how far it is safe. So DC ratio only you need to check, it should not be more than 1, it has to be lesser than 1, and this is how actually you will be defining it generally. But if you want to design it, you can go for design also if you want to. Now in this case, few more things you can give the stiffness modification factor also for the section designer elements. These are not the regular section elements. These are quite irregular sections, but still you can define the SMF over there. Few more things I wanted to show you, that in the latest version there is a possibility of you can import. There is an option, actually in this version it is not there, but there is an option actually you can import the geometry from the CAD. Okay, you create the geometry, like let's say for example I am having a geometry which is a little bit weird, something like this is my element, but it is very difficult to draw it. I hope you are getting what I am saying, because how the angle is coming, how much is the length and all, with this graph paper it is not possible. So what you do is you create it in CAD, which basically in the AutoCAD, you create that as a DXF and you import that as a DXF. The only thing is the 000, or which is this point. This point is the CG of that. Okay, so this is a little weird. So I'll be explaining it to you in a little bit elaborative way. I hope it's okay. So I'll go to the CAD. So CAD actually, see, there is a point of which we call it as the center, and there is a point which we call it as the the geometric center or the physical center. So both the things actually need to understand how it is to be modeled in the mathematical modeling, so that it would be comparatively easier for you. So I'll just open any particular new file. Okay. So in this case, this is 000. So imagine that you are having certain lines and all over here. So I'll just draw the PL, which is the polyline. Imagine that this is your section. Now how to draw it, also there is a skill that you need, whether to draw it like this or how to move that, what is the center and all. Actually it's a crazy way, to be very honest, to understand. Okay, so what you do is such kind of properties, you require the mass properties of this particular object. So here if you see that it's not solid, so region is to be selected. Okay, so this full, actually I'll be calling that as a region. So this one region is getting selected. I know that you might not be knowing to see this, how to create the region. Now here you can see that the region is got selected. I'll just draw the F2 command. So region was not there initially, so I have given the region command and then I have created the region. Are you getting what I'm saying? Okay. So once the region is getting selected, so this will be considered as a region. The boundaries will be sealed. So after doing that, you go to the mass properties, enter it, and then just select it and just right click it. Now here it is the centroid. This point is known as the centroid. There are so many other properties are also given. We call it as the radius of gyration. We call it as the moment of inertia, how much it is, and many other things. So out of that, the centroid point is very important for us, which is minus 28.96 and minus 21.89. So I'll just draw the diagram. Okay, so this is the point. So this point is the centroid. Which one? This point is the centroid of this. So ideally, this particular center point is nothing but the centroid of this. So what do you mean by that? So if you go here, what is the centroid point is not this centroid, which is X and Y center. The centroid point is the the blue color. This is the centroid point. So ideally speaking, this centroid point should match with this centroid point. Why? Because whenever you are drawing any particular column over here, it would be considered it as a marking is considered it as the centroid point. I hope you are getting what I'm saying. So let us say that I'll be drawing that centroid point here. Just a minute. I'll go back to this place, call it as, let's say, this one, section 2. Let's say this is the element, section 2. And I am selecting this point and I'll be giving this as a F section 2. Okay, so if you see this, actually this is the centroid point. This point, the joint which I have selected is the centroid. So this centroid should be matching with this centroid. Are you getting what I'm saying? Okay, so how to do that is through the magical software AutoCAD. Through this, you will find out exactly where is the centroid point. How do we do that? Again, I'll show you. You draw any particular PL line. I hope you are drawing it properly based on the requirement that you guys are having. After that, you create region, R-E-G-I-O-N. Region, enter it. You just select it and right click it. Once you do that, you give a command called mass properties. M-A-S-S-P-R-O-P is the command. So once you do that, you will get the centroid point. This is the centroid point. Got it? Through the centroid point, try to figure it out where exactly it is coming. So these are the coordinates. This is basically based on the requirement. So minus 3, 435 and 791. 345, 791. So this is the point. This one is the point, which is the centroid of all this. So you should be drawing it based on this. So ideally speaking, please pay attention carefully. So I'll be giving 0, 0, 0. So what I'll do is, I have to move this with the reference to this point and copy it to 0, 0, 0. Now this particular object I am ready to import it in the ETABS section designer. Okay. In the section designer. Now, is it available in 16.2.1? No. It is. In which version it is available? I think 19 onwards they have started, that functionality of importing that. Actually, that particular object, you can import it here. Understood? So this is how actually the section designer can be utilized for the complex projects or the complex shapes. Believe me, I still remember actually I was having a kite section column. It took me a lot of time, dear, that how to draw it. Okay, first of all, I used to draw that as a line somewhere. Like, the kite shape is something like this. So this is easy to draw. It's easy to draw, but is this the better way? Is this the good way to draw it? No. Why? Because you will be modeling this point as from the reference of this, but whereas the CG point is somewhere here, so this point should be coming to this area. Okay, so this is little difficult to model. That's the reason you should be using the CAD for this, and this is how actually you'll be using the AutoCAD for this. Alright, so few more things I wanted to just tell you, that at least for 15-20 minutes you should be spending some time with the CAD as a software. Why? Because many people were facing the problem of drawing certain things or the detailing certain things. I still remember one of the guys given me suggestion few minutes back that he's working with one of the company and everything is perfect. He told me that the company level is here, Econstruct level is somewhere here, but still, many people are admiring whatever I'm saying and all actually, but I am facing problem in the detailing area. So detailing is something which comes through the CAD, and CAD is something which comes with the practice, nothing else, absolutely nothing else. CAD cannot be taught, it can be only practicized. Alright? The teaching or something actually L enter, PL enter, fillet, which we call it as F enter, or maybe whatever you are doing, trim, TR enter, all this actually it comes with the reflex action here. Okay, the speed of the CAD would be increased only if you guys starts practicing it. So I would take this as a call from one of our alumni actually, because he has already cleared the exam today only. Okay, and he has got placed in one of the company, and obviously certain problems that he was facing, and this is what actually I would like to teach you, that the column detailing, beam detailing and the foundation detailing, we are making it mandatory. Okay, for each project you need to do, not for the entire building, but one column, one beam, full beam actually, continuous beam you should be taking. Okay, and one slab, one entire floor slab and the foundation. Is that okay? So each one of you would be doing it in CAD, AutoCAD. Got it? I want to show you that also later on, probably before the end of this session, we will be explaining you why it has been coming to that particular level. Because believe me, the detailing is one of the very important part that is going to be played in many companies. Alright, so this is how it is, the definition dialog box which we have discussed, which is like, let's say for example from here, another one feature which I wanted to show you, that is basically the non-prismatic section, auto selection. Non-prismatic is whenever you are having the variable change in the sizes. So if you are having the inclined beam or a T-shape, or variable depth actually, generally the corbel is having variable depths, so those kind of things you can define it here. Auto selection is generally from the particular set. If you want to select certain, let's say the top chord is there, bottom chord is there, so let's say this is top chord, I will give this as a top chord. Similarly, I will add the bottom chord and all actually. Now, some of you might not be understanding what I'm saying is, let us say that this is the truss. Let's say I'll make it simple, that is, this is the end truss. So this one is top chord, This one is bottom chord. And what are these is truss elements. I do not know basically that I'll give this as a fixed support and this as the roller support. Okay, so this is the pin support, not the fixed one. Pin support, and this is the roller support. Okay, if this is the situation, then how basically you are going to, model it, because you don't know basically what is this top chord for. Are you going to use the I section? Are you going to use the channel section? Are you going to use this kind of section? Are you going to use this section? Are you going to use the box section? Are you going to use the channel, the circular section, hollow section? So which section you will be using it here? You do not know. So what you do is you create a set which is top chord, in which section 1 1, 2, 3, 4, 5, n. You add this section as a top chord. Then similarly you add another section as bottom chord. In the bottom chord also you add the section 1, 2, 3, n. And this section will be allocated here. This section will be allocated here. Similarly, the third one, we call it as, let's say, the truss element. Here also you will give section 1, 2, 3, n. And this section you will be allocating here. Here means here to the truss elements. And then software will decide that this one is the most critical areas or we require this. Can you give me a moment? I'll just close the Yeah, I'm sorry for the disturbance. So this is the top chord, bottom chord. So based on the requirement, actually the software will find out which one is the best and will be allocated here. So this is how actually you will be defining varied variety of the sections, including the auto sections or whatever the sections that you will be utilizing and allocating. Understood? So this is how actually you'll be defining these sections, which is the section types. Similarly, there would be the tendon sections would be there. Now this is simple actually. You will be giving the material properties that is available in the market, and you will be giving how much is the square strand area for. So this is very simple. Why? Because depending upon the requirement, actually you'll be giving availability. You need to check it first. And then you will be giving the tendon properties here, which is basically for the post tensioning and those kind of areas. Where to utilize this and all also we'll see it later on. Okay, you can draw the tendon properties from here. So this is, let us say you want to draw some tendon. So from here to here, you are going to draw one tendon, and this particular tendon you will just select it and add it as a tendon property, whether it is a curve and all. Actually you can refresh it. Okay, so this is also important that you give that as a reverse parabola or something. We'll be looking at, don't get scared, we'll look at it a little later on, particularly while working in the SAFE software. you will be utilizing this once we will start working with the PT designs and all. Alright, so can you do the PT design in this and all? Yes, PT slab design is possible. PT beam design is not possible. In the entire CSI family, PT beams are not there. It is you cannot design the PT beams in the model or analyze or design the PT beams in the any of the CSI family. Then when to use it, where to use it and all, how to use that and all, actually then you have to use the other specialized software for the PT, because it is always and always it is third party vendor. So that's the reason we are not emphasizing much on the post tension slabs and all. So anyway, eventually later on I'll be explaining it to you a little to certain extent, so that you guys can be able to at least address certain issues. Okay. So we'll take certain doubt clearing sessions today. Yeah, I'll just allow you to unmute yourself. Yes, can you put your cameras on, please? Thank you. Yes, any doubts, anybody? Hello?
Hello, sir.
Yes.
Sir, while defining concrete, we are not concerned with the ratio while defining.
No, we are basically interested in two things. One is the E value. EI, correct? No, you define 2 times EI, 3 times EI. You know that during the college days we used to write down 1 EI, 2 EI, 1.5 EI. One is the E value, another one is the I value. I is the moment of inertia, which will be, BD cube by 12. If it is, depending upon the requirement, actually, you will be giving the section size. And E value is basically from the concrete. So 5000 root FCK, that's the formula as per Indian code. But if you go to other international codes, the formula is changing. Okay, so this is how actually EI is important when it comes to the analysis, because based on that, the stiffness will be calculated. EI, 4 EI by L is the stiffness value, right? So you know the 4, you know the E, you know the I, and you also divide by L. You also know the length. Length means, length means, let's say this is the beam. How much is the length from here to here? So if you right click it, you will see that what is the size of the beam. So based on, and what is the material, which is E as a material. I would be the BD cube by 12 and length will be this length. So it will be calculated based on the length and the material and the property of this. So more than that, how are you going to achieve is not the software business. So your problem is how the hell we are going to acquire this as M70 grade. So this comes under the concrete technology, my dear. It doesn't come under the structural engineering era only. It comes under the, there is a MTech in construction techniques and management. So those people generally will have that kind of issue that M70 cannot be achieved without having the silica fumes. Correct? So if you want to address that question also, I'll show you. That's not actually as per this course is concerned, but still, see, imagine that you are having this circle in which you will be having the, this is the aggregate. Okay, so this aggregate, there would be voids in between. Am I right? So this aggregate, inside this, there would be the, this is coarse aggregate, this one will be the fine aggregate. Correct? The voids would be filled up by the fine aggregate. After the fine aggregate, the void in between will be filled up by the Sometimes the fine aggregate also will be of one nature, or sometimes two fine aggregates also will be there, or directly the cement will be there. So this one will be the cement. Also there will be certain gaps in between, so that will be filled up by the silica fumes. So it has to be dense. The more density is having, actually more strength you will be getting. That is the technology that we are talking about. Got it. So unfortunately, if you ask me, that is not in the purview of structural engineering. You are only required to get that much amount of Newton per mm square, you are getting it or not. That's how you should be thinking. Okay, any other doubt?
Sir, you were saying about the modeling of T-beam.
Modeling of?
T-beams in slabs. In the
PT beams or pre-engineered structures?
no, sir, T-beam. Rectangular
T-beam. Okay. I heard it wrongly. T-beams. Okay.
Where we can use the T-beam.
Yeah, see, T-beam, currently all the beams are T-beams, am I right? This beam will be the L-beam. Why L-beam? Because this slab will be, straight, and it will be like this. So it's L-beam.
Displaying.
Sorry. Yeah. Generally at the corner it is basically the T-beam, the L-beam. At the edge, internally it will be the T-beam. To give you the glimpse, actually I'll just show you. See, I am having a slab here like this, and this is a slab, and I am having the beam, let's say for example, this is one beam, this one is another beam. Okay, so the nature of this beam would be the L beam. Do you agree? Because if you take this, as it will consider it as slab and beam will act together, right? This will be act as a L beam, and then here this will be act as a T beam. So what I'm saying is, you forget about T and L action because this is basically a slab. Let's design or model this slab as a thin shell, which is basically, it will take the out of plane bending also. So what I'm suggesting you is, do not use L beam, do not use T beam. Instead you use the slab as a thin shell. So depending upon the meshing, it will automatically take the stiffness. That is the best way, believe me. Okay, so ideally you should be using the T action and L action only if the slab is membrane. And believe me, if you go to the industry, many people, they use the membrane action of the slab only. So in that case, you should be using the T action or the L action. So, but that is not that professional way of dealing with the structures, I feel, honestly speaking.
So if we take self-in, sir, we will design it as a rectangular beam also.
Yes, we will be using this as a rectangular beam, but automatically the bending action and all will be taken care by the slab thin shell elements. Okay, yeah. Okay, any other question, anyone?
Hello, sir.
Yes?
But in case of different type of slab, like waffle slab and different type of slab, the SMF value will be same or different?
Yeah, when it comes to the slab, it's a flexure and bending with the deflection as a parameter, right? So it is same only. The stiffness modification factor will be similar, I would say. Unless and until if you go to American Standard, or if you know that I've given the PDF copy also to you. So during that time you will see that, you will see if it is a flat slab, the SMF is different. Normal slab, the SMF is different. So, but as per the Indian context, you have to follow the code. Nothing. You cannot define your own, your own parameter and add it. So otherwise, people will say, the authority people or sanctioning people will say that from where you got these values. So it's better that you utilize the same value given by the code. You should not be using any foreign values over there. Yeah. Yes, any other question, anybody? Okay, I would like to give you the small homework. We don't have the system to follow the homework. We think that everybody will do it. I'm sure that everybody will keep the promise what I'm showing you. You just need to go through each and every option and note down what you have understood. Is that okay? See, there is a tool tip also. If you go here and if you just press F1, the software will show you what it is. Okay, so at least before coming to the tomorrow's session, what I'm suggesting you is go through every option. Okay, note it down on the piece of paper. Let's say this is mass source, and if you go here and just say F1 and just whatever you have understood, note it down. Is that okay? Right? Why? Because I'll tell you very honestly, this option is extremely important. I'm sure that you might have realized by this time. Okay. What all the things are there in the library functions, you will be utilizing it in many different ways. Okay, and imagine that you are a student and you don't know what kind of books your library is having. Actually, you're not a good student. Am I right? So just go through the definition dialog box. Actually, what is section cut, group definition, spear numbering, span number. I'm sure that it won't take more than 1 or 2 hours. Is that okay? Who will do this exercise? Please raise the hand. Okay, so everybody is taking oath. Yes, good. Fine. Okay. So see, when we'll start tomorrow, actually this it will be very easy for you. Nothing else. Okay, it will be refreshing. Okay, I have seen this, so it will be correlated also. All right, guys. Any other question? Anybody? So, are you guys doing practicing every day? Practicing?
Yes, sir.
Yeah.
Yes, sir.
Okay. So, is it really helping you guys?
Yes, sir.
Huh?
Yes, sir.
Sure, right? Okay. Somehow, actually, today I do not have that recording with me, but maybe within a couple of days' time, actually, I'll show you. Because today we have taken the interviews, and believe me, some people have told us that you please focus on the detailing part because we are struggling. People,
Yes,
the guys have recruited in the companies and they are saying that we are okay with the modeling, analysis, design, stability check, everything is wow. But whenever the detailing comes, the speed breaker comes, the bump comes. Okay, so. You don't know in which company you will be working, correct? After maybe a couple of years or 5 years down the line, nobody knows, correct? So you should be equipped for handling all these challenges. So CAD is something that, if you start practicing it right now, it will be easier for you. Okay, so please start doing practicing the CAD. Believe me, when I was there in Dubai, Even if you go to London and all those kind of countries, civil engineers are doing the person who is a designer, he will be doing the detailing work. There will not be any other detailers. Like in India, okay, some diploma guys or maybe ITI guys also they will take for as a CAD draftsman and all actually, or somebody has done the course also they will take it as a CAD draftsman. But if you go to London or in certain countries like in UAE also in some areas I have seen that they prefer the designers, means I am designing it so I should be detailing it. If I give it from, let's say, from my side, if I give it to, let's say, Prasun, okay, you draft it. So Prasun will understand by his own way and he might do the mistake, correct? But if Prasun is himself is designing and he himself is editing it, then the chances of doing mistakes would be reduced. Am I right? Yes? Yeah, so this is how actually you should be thinking, and don't think that, this is not my work. Okay, when it comes to the structural or a civil engineering, everything is, my work. You take that as a responsibility and, start working ahead. That would really help you out. Okay. So, any other doubt anybody is having?
Sir, for the detailing, can we use software or AutoCAD is the best?
Yeah, AutoCAD is the best software even today, to be very honest. Many top companies are also, they are, dealing with the CAD work only. Yes, there is a software called RCDC, some people are using it. But if you go to the, A grade or B grade companies, you will see that AutoCAD only people are preferring. If you go to C grade, D grade companies, then they will take some shortcuts because they want to, reduce the budget in the drafting works and other works. So you think that which company you want to go. Okay. Why I'll tell you, there is a reason also. Yeah, why there is a reason also. If you go to those kind of companies, no. Just a minute. I do not know if I'm having that kind of files with me right now. Many people, I'm sorry, actually, I don't have the files here. When you go to the structural detailing, no, just a minute, I think I'll just check it. No, I don't have it. Anyway, I'll just give you certain files. Yes, sorry, I have. I'll just show you this file actually, so that yeah, look at this file. Is it possible to do it in the CAD way? Sorry, without CAD. It's impossible. I'll show you the reinforcement detailing also. Now, I want you guys to, draft it with some of the softwares apart from the CAD. It's impossible. Believe me. Okay. There is a staircase here which shows like this. There is a dotted line here. There are markups here. How can you draw it without CAD? Or can it be drawn with certain software? You manage everything, I'll just give you the inputs. No, it doesn't work that way. You have to model, draft it in CAD only. Understood? This is how it is.
For us, we are doing all project detailing, so it will take more time, sir.
I'm not asking the entire project detailing. I'm asking one element. There are, let's say, 200 columns. I'm asking only one column to detail.
Okay, sir.
Is it a very big work?
No, sir.
But don't take only one column, top floor only, one beam is, dobara, ho gaya. Yeah, 2T12, 2T12, finished. Don't do that. You take the continuous beam, a little bit complicated beam, so that you will know actually what to draw. See, in CAD, I'll tell you very honestly, 50% or more than that people, if I give you this reinforcement now, they cannot draw this. In the group, currently, I have to show you this, then only you would be able to, and in that also 50% people will be doing the mistakes. What I'm saying is, you start drawing it so that we will start correcting and will start helping you out. There is a waterproofing layer, there is a typical section for 1000 thick raft, there is a PCC layer is there. You can see that there is a waterproofing layer. This one is waterproofing layer. This is PCC layer. This is the reinforcement, bottom reinforcement. This one is the reinforcement which is going in the other direction. This one. So T20 at 200. Distribution steel, main steel, then the basement level, filling level, how much is the depth level, total depth, retaining structure, how much is the offset distances, all these things, how much is the anchorage L length, what is the scale, many things are there. You might miss few of them. Don't you want to learn how to draw this? First one is what to draw and then how to draw. These two things only questions will come. Are you getting what I'm saying? If I tell you that this is, based on the retaining wall, actually the 1 meter raft is there and T25 at 200 center to center, which is bottom steel. Top steel is T20 at 200 center to center. You please give me the, detailing sections. This is how you need to start detailing it. Okay. And once you start detailing only, we would be able to check it and will be confirming. You will go to the Google, see the Google areas through which what kind of sort of detailing is to be required. You will start investigating. Understood? Many people, they depend upon the, draftsman only. So, nahi chalega. It will not happen that way. Many people are there dependent on the mason only. Mason only tells the engineer, sir, aisa nahi hota, aisa hota, that way. So he becomes an engineer, he will become an idiot. Correct? That has happened with so many sites. Am I right or wrong? Tell me, am I telling something lie here? Many fresher engineer, actually masons only, they on the site they teach you. And they will help you to learn and become a real engineer. Yes or no?
Yes.
They work more than the professors and HODs and all actually in your colleges. HOD professors and all actually they will help you only with the paper. B.Tech, this guy, M.Tech, this guy. That's all it is. The real sense of engineers will come when you see the practicalities and the detailing and all. This drawing goes to the site. Start doing it. Matter ends. That's it. Understood? Yes or no? Now this drawing is created by a company called Sterling. करीबन 1000 के करीब स्टाफ है उनका. Yeah? So such kind of people are working with, dedicated, civil engineers, site engineers, structural engineers, project managers, who will be, going to the site, checking certain things properly. This is how actually they work. So you guys need to start working with that kind of system. Okay, this is one set of drawing. So many other sets of drawings are also there. Shear wall detailing. This is shear wall detailing.
Yes.
And it is not difficult. It's very simple. Okay. How it has to be drawn. Okay, so this is the column. Column will be detailed it separately. Shear wall will be detailed it separately. This is the shear wall in which the top steel will be there, bottom steel will be there. There will be the straight bars, horizontal bars we call it as, and there are links here. Got it? So you need to work on all these aspects so that the scale will be there, which particular shear wall is there, what is the thickness here. All this comes under the detailing part. So you start working with this today, not yesterday, बाद में देखेंगे, बाद में procrastination approach itself is wrong. Okay, बाद में that will never come. Today, at this moment, I'll start. That's why I asked you that who will do that. Everybody says we'll do that. And there also some people say कि करेंगे देखेंगे बाद में. After the session gets over, you will be working with something else. Yeah? Don't do that. Okay?
Sir, can we get this detailing files? Yes, sir.
So we are giving these videos only, no?
Sir, this
See, what happens is, I'll tell you, if you give these files, no, most of the things will be copied from this file only. I want you guys to generate it by yourself. Is that okay? Copycat हो गया अभी वो ज़माना गया. If you go, if you really want to ride the vehicle, sitting backside will not help you. Do you agree what I'm saying? Yes, you can draw even better than this, not just like this. Okay? How you are going to draw, slowly you'll start. I want you guys to learn, skill yourself. Just copy and all. If I give this file, now I'm sure that everybody will start drawing like this only. Why? Because it is just copy and paste. I don't want you to be like this.
Sir, detailing tutorial videos.
Detailing tutorial videos are also there. Our CAD videos are also there.
Sir, CAD we know, but detailing part we don't know. I don't know, sir.
That's what I'm saying. Simple है क्या है इसमें? Rectangular. This one line. These are lines. These are lines. These are lines. This is line. This is text. This is text. This is dimension line. These are lines. What else is there? See, whenever actually, I'll tell you what happens is when you draw the circle, no, that circle will become bigger than this. 16 mm, otherwise it will become a dot. Because the circle, actually, the scale of the rebar is different than the scale over here. So I want you guys to learn that kind of minute work. Are you getting what I'm saying? Okay.
Yes,
and forget about this. If you go to Google, how many number of sites are available? Thousands of sites are available. Why you want only this drawing? Okay. See, drawing shear wall this is not something you need to learn. I want you guys to learn why this particular reinforcement is given and how it has been given. You already are going to be expert in the ETABS and SAFE and also in the designing part. Based on that model, you need to draw it. That is what I want you guys to be expert into. So that you can give proper suggestion to the draftsman. You should not be doing the mistake.
Sir,
I don't want you to be a draftsman as a person. No. I'm not talking about that. I'm talking about how are you going to instruct the other people, the engineers, the drafting engineers. If he does the mistake, who is the responsible? You are responsible. Am I right?
Yes, sir.
Yeah. Yes. Any other question?
So will the detailing part come after design or we should?
Generally, it comes after the design, but the CAD related things requires a lot of practice. That's why I'm asking you, requesting you rather, that you start working as early as possible.
So then without design, how should we decide bars and all, sir?
You give nominal bars, do bar to de do, at least minimum rebars as per the code.
Okay, sir.
You are not completed design. Okay, what is the minimum reinforcement given in the code? You apply that. एटलीस्ट विल कम टू नो, अरे भैया मिनिमम तो देना, वो मिनिमम कितना है देखो, बीम में, स्लैब में, कॉलम में. यू विल स्टार्ट एटलीस्ट इन्वेस्टिगेटिंग दैट. या बाहर ही नहीं देंगे, डिजाइन ही नहीं किया है, बाहर ही नहीं दिया है. Okay. Immediately you should start acting on it. You should not be just copying or doing something. People have, once the exam comes nearby, or the pressures comes up now in the submissions and all, actually some people, they take the shortcuts that CAD work I will not give, this work I will. There is no time only. Right now there is a time, you investigate in that. So you have already created the detailing of the for the project number 1 or assignment number 1. Assignment 2 will be same thing, right? Only the rebars and certain things will change. Editing takes a lesser time rather than recreating it. Am I right?
Yes.
So start working on those areas. And there is nothing shy in that. Learning CAD. Believe me, one of the 65 years old person actually is a consultant in Mumbai. He has taken 3 months leave from this course only to learn CAD. He said that I will learn CAD 100% and again I will join the course. I said, wow, if you are taking break to learn something, go for it. Okay, so practicing consultants are taking such kind of decisions. Okay. Why he has to take the leave? Because he is already a consultant, and because 65 years age, he cannot learn that fast like you can learn. Anybody wants a workshop on Android? 1,000 rupees is the course.
What workshop, sir?
On Android. How to learn Android. Nobody needs, correct? Because everybody knows. Yes or no? iOS, Android. Why? Because every day you practice, right? Yes or no? Similarly, CAD work also, if you practice, that it is that simple. Believe me. Okay, so that's the reason you start practicing it. You don't need any special coaching for that. He is a 65 years age and he is already busy with so many people. That's why this is his personal call. You don't take that call. I will take sir 3 months. Sir, look at your another. He's taking 3 months. I will also take 3 months. No, don't do that. He's already established consultant. Okay.
Hello sir.
Yes.
तो अगर हमारे को सीयर बॉल में सीयर एनफोर्समेंट 750 आ रहा है, 750 mm स्क्वायर पर मीटर, तो उस केस में हमें जो डिस्ट्रीब्यूशन बार है उसी को कंसीडर करना है, रिंग को भी कंसीडर करना है shear?
No. Shear means actually only the horizontal rebars will come. The links will not come. That's what actually I have shown you. Now, see, when the question comes, I'll go into deep. Otherwise, I won't go. Okay.
Yes.
This one actually, the horizontal rebar comes for the shear. The links will not be transferring the force. Links is basically to maintain the distance between this and this.
ओके सर. तो सर अगर हमारा 750 आ रहा है तो रीबार जो डिस्ट्रीब्यूशन बार है वो ज़्यादा जा रहा है मेन रीबार से.
So 750 divided by 2 you need to do, because 2 side it will come, right?
ओके सर.
So 750 divided by 2 it will come like this, and then you check how much spacing and how much rebar you need to give, and minimum how much it is to be given. Based on that you can find out. It will come in the range of T8 at 200 or 250, something like that. So even if it is not required, people are giving this much. Why? Because utna to chahiye at least. You cannot give T6 at 1 meter. Can you give like this? On the side it will fall down. These rebars actually, the vertical rebars will not be able to stand. These are main rebars, correct?
Yes,
These are the main rebars which goes vertically. It has to confine, it has to hold so that it doesn't go here and there.
It should not be less than 12, na sir?
Which one? No, horizontal rebars can be of 8 mm.
No, vertical.
Vertical, yes. Vertical is 12 mm. Generally we give 12 mm.
shear wall में 10 भी यूज करते हैं.
10 भी यूज करते हैं shear wall में. 10 भी यूज कर सकते हैं. But it is preferred to go for 12 mm. See, if you see that 10 mm, if you go to the side and if you see 10 mm, no, the bar with itself, it will start buckling.
Yes, sir.
How many people have worked on the side? Please raise the hand.
Yes, sir.
Yeah, if you go to the side, if you just make 8 mm stand, it will start buckling with its own self-head.
Yes, sir. बंडल भी बकल करने लगता है अगर 8 बार का कॉलम हो तो वो भी बकल करते हैं.
So do you want to use that? Some people they say that no, it won't buckle because we'll be bracing it from both the sides and all actually. But still the compression capacity of 10 mm bar itself is so weak actually. That's why, do you think that IS code is an idiot? That's why people are saying that you use 12 mm bar, minimum bar. You increase the spacing, no, to certain extent. It won't buckle by its own self-weight at least. Okay.
Okay. Then how we decide the rings in shear wall? Links.
Rings is basically IS 13920. See, now the questions have started coming. Thanks for that. Correct?
We can do one alternate.
So suppose if the spacing between the two, if it is more than or equal to 150, then you can give alternate rebar. You can skip one rebar here. But if it is like this, if it is 200 or something, every rebar requires the link. We call it as confinement of reinforcement. See, the questions will come like this. That's why I'm not giving this kind of files, because we want you guys to start thinking from that side. Okay. Fine. So two homework. One is actually like this one, and another one is start practicing. Only single egg column banao, egg beam. Will you show at least one column, one beam tomorrow?
Yes, sir. Yes.
One single column and one single beam. I'm not asking too much.
Sir, final.
See, if you go to 12 standard and 10 standard homework, now it was bundle of works. History, geography, this one, that one and all actually. Till the time you come to you will go to the company now to start earning actually. Nobody want to do any homework. सर आप खाली लेक्चर दे दो, हम लोग ऐसे पॉपकॉर्न खाते देखेंगे, और फिर जॉब चाहिए. ऐसे नहीं होगा. धीरे धीरे इफ यू स्टार्ट थिंकिंग एंड वर्किंग, नो, ऑटोमेटिकली job will see. Last batch, many people have already got the job before exam, before interviews and all. Okay, everybody will get in this batch also. You just do the little bit hard work. I will only not leave you guys. Okay, fine. So thank you. Yes.
What will be the timing for tomorrow's session? Last time I requested, sir, it is Friday, sir. If it is feasible, please.
Yeah. What would be the best timing? Friday?
Generally, it is 2, maybe 3. Sir, if it is feasible for other students, also ask them. If it is
We'll keep it at 3 o'clock. Is that okay, everyone? Instead of 2 to 3, it will be 3 to 4.
Yes, sir. Okay.
Is that okay? Tomorrow it's a Friday and it's a prayer day.
Yes.
Yeah? Okay? No problem. Thank you so much. Yeah, it is tomorrow 3 o'clock. Yeah?
Thank you, sir.
Okay, thank you. Yeah, see you tomorrow. Bye-bye.